Application of derivatives, miscellaneous exercise, page number 242. Let us continue maxima minima questions. Question number 8. This is an important question. Find the maximum area of an isosceles triangle inscribed in the ellipse x square divided by a square plus y square divided by b square is equal to 1, with its vertex at one end of the major axis. Let us draw an ellipse. X axis, y axis, and this is the origin. We have to inscribe a triangle with its vertex as one end of the major axis. Let me inscribe a triangle. I am taking the vertex on the left side of the major axis. We will take this point as a cos theta, comma b sin theta. We are using parametric form so that we will have only one variable theta instead of two variables x and y. We have to maximize the area of this triangle. The x coordinate of this point is a cos theta and y coordinate is b sin theta. So, base will be twice of b sin theta and this length is a. So, height of the triangle will be a plus a cos theta. Base of the triangle will be 2 times b sin theta and height of the triangle will be a plus a cos theta. Let a be the area of the triangle which has to be maximized, half b h, half into base is 2b sin theta and height is a is common, we can take it out. We get a times 1 plus cos theta. AB sin theta times 1 plus cos theta. Here we have only one variable theta. That is why we use parametric equations. Let us find the first derivative. With respect to theta, we are differentiating. A and b are constants. We are going to use product rule. U and v. U dashed is cos theta times v plus u into differential of 1 is 0, differential of cos is minus sin theta. We get AB times, let us open the brackets, cos theta plus cos square theta minus sin square theta. We have two ways of solving this equation. We can use cos square minus sin square formula, which is cos 2 theta, or you may change sin square using the identity 1 minus cos square, but in that case you will get a quadratic expression, then you have to factorize. So, it is better to use cos 2 theta formula. We will use cos x plus cos y formula, which is 2 cos x plus y by 2 and cos x minus y divided by 2. This is equal to AB 2 into cos of theta plus 2 theta is 3 theta divided by 2 and cos of theta minus 2 theta is minus theta and divided by 2, and we know that cos of minus theta is cos theta. Therefore, we get 2AB cos 3 theta by 2 and cos of theta by 2. Equate this to 0. cos of 3 theta by 2 is 0. Therefore, 3 theta by 2 is pi by 2. Therefore, theta is pi by 3. And here we get cos theta by 2 equal to 0. Therefore, theta by 2 is pi by 2. Therefore, theta equals pi. But this is not possible. Area will become 0. Area is minimized in this case, because when theta is 0, theta is this angle. If theta is 0, this point coincides with the vertex. So, the triangle becomes a point. The area is minimized in that case. Now, second derivative test. D square A divided by d theta square is equal to, let us differentiate this step. If you take the next step, we have to use product rule, which can be avoided. AB into differential of cos theta is minus sin theta, and differential of cos 2 theta is minus sin 2 theta times 2. Let us find the second derivative when theta is pi by 3. We get AB times minus sin pi by 3 is root 3 by 2 minus 2 times sin 2 pi by 3. Sin 2 pi by 3 second quadrant angle. In the second quadrant, sin is positive, which will be same as sin pi by 3. This is root 3 by 2, and both are negative. So, the answer will be negative. Therefore, area of the triangle is maximized. When theta is pi by 3. And check the question, find the maximum area. Therefore, the maximum area of the triangle is equal to, area of the triangle is AB sin theta into 1 plus cos theta. Substitute theta as pi by 3. We get AB sin 60. Sin 60 is root 3 over 2 and cos 60 is half. 1 plus half is 3 by 2. Root 3. 3 root 3 divided by 4 AB square units. This is the maximum area of the triangle. Question number 9. A tank with rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meters. So, height of the tank is given as 2 meters and volume is a constant, which is 8 meter cube. If building of the tank costs rupees 70 per square meters for the base and rupees 45 per square meter for sides, what is the cost of the least expensive tank? We have to minimize the cost. So, let C be the total cost, and we will take the length of the tank as x meters and width of the tank as y meters. C be the total cost. Area of the base is x into y and the cost is 70, and area of the four walls is 2h into L plus b. 2 into h is 2, L plus b, x plus y, and this cost is 45. We get 70 xy plus 180 times x plus y. We have two variables, we have to change one of them. Volume is given, volume of the tank is LBH, is given as 8. L is x, breadth is y, height is 2. Therefore, y is 4 divided by x. Let us substitute 70 times y is 4 divided by x plus 180 times x plus 4 divided by x. Now, let us differentiate with respect to x. 70 into 4 is a constant, derivative is 0. 180 times differential of x is 1 and differential of 1 by x is minus 1 divided by x square. That is 1 by x can be written as x raised to minus 1. Use n into x power n minus 1 differentiation formula. Therefore, it becomes minus 1 over x square. 180 times 1 minus 4 divided by x square. Equate this to 0. We get 1 is equal to 4 divided by x square. X square is 4. Therefore, x is plus or minus 2. But here it cannot take a negative value as x cannot be negative. Therefore, x must be 2 meters. Let us do the second derivative test. D square c over dx square is equal to 180 times differential of 1 is 0 minus 4 times x raised to minus 2. Minus 2 differentiation is minus 2 x raised to minus 3. Minus and minus will become plus, all are positive quantities. So, second derivative is positive. Therefore, the cost is minimized when x is 2 meters. Now, check the question. What is the cost of the least expensive tank? So, we have to find the cost. Cost is equal to, we have written the cost here, we will use this step. We need not find y, we have only x in this equation, let us use that. 70 times 4 is 280 plus 180 times x is 2 and 4 divided by 2 is 2. 280 plus 180 times 4. 280 plus 720. Therefore, the total cost is rupees 1000. Question 10. The sum of the perimeter of a circle and a square is k. So, perimeter is a constant. We will take radius of the circle as r and side of the square as a. So, total perimeter of the circle is 2 pi r plus perimeter of the square is 4a and this is k, where k is a constant. So, from which we can find a in terms of r or r in terms of a also you may find. Therefore, a is k minus 2 pi r over 4. Prove that the sum of their areas, let A be the total area, which is equal to area of the circle is pi r square and area of the square is a square. Let us substitute for a, because we have two variables, we are changing it in terms of one variable. K minus 2 pi r the whole square divided by 16 4 square is 16. We have to show that the side of the square is double the radius of the circle. This is the result to be proved. Don't use that result at the beginning of your answer. Let us differentiate a with respect to r. 2 pi r. 1 by 16 is a constant. Differentiate the power first and then the base. Don't forget to differentiate the base. K is 0, differentiation is 0 minus 2 pi. 4. We get 2 pi r minus pi by 4 times k minus 2 pi r. Equate the first derivative to 0. We get 2 pi r is equal to pi by 4 times k minus 2 pi r. Pi gets cancelled. We get 8r is equal to k times 2 pi r. Two r is common. 4 plus pi is k. Therefore, r is equal to k divided by 2 times pi plus 4. Now, let us do the second derivative test. D square a over dr square is equal to, we will differentiate this step, which is 2 pi minus pi by 4 times k is a constant, derivative is 0, and minus 2 pi. Minus of minus becomes plus. All are positive quantities. We have plus sign in between the terms. Therefore, it is greater than 0. Therefore, sum of their areas is minimized. When r is k over 2 times pi plus 4. Now, let us check the question. We have to prove that the side of the square is double the radius of the circle when it is least, when the area is the least. So, side of the square we have already taken a as k minus 2 pi r over 4. Get the result, a is equal to 2r. So, let us eliminate k. K is 2r times 4 plus pi minus 2 pi r over 4. Open the brackets. We get 8r plus 2 pi r minus 2 pi r divided by 4. 8r divided by 4 is 2r. Therefore, total area is the least when side of the square double the radius. Next question, question 11. This is also an important question. A window is in the form of a rectangle surmounted by a semicircular opening. So, we have a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meters. Find the dimensions of the window to admit maximum light through the whole opening. So, we have to maximize the area. We will take the length of the window as 2x, so that the radius will be half of it, which is x, or you may use x and x by 2 also, and take the breadth of the window as y meters. So, radius will be half of the length, which is x meters. Now, perimeter of the window is this length plus these two and half of the circle, this portion, which will be pi x. 2 pi r is the whole perimeter of the circle. It is a semicircle, so half x. Therefore, perimeter 10 is equal to 2x plus 2y plus pi x. Therefore, 2y is 10 minus 2x minus pi x. Let us find the area. Let A be the area of the window, which is area of the rectangle, length into breadth. Length of the rectangle is 2x. So, 2xy plus area of the semicircle. Area of the circle is pi r square. It is a semicircle, so pi x square over 2. Now, we will substitute for y to change it in terms of one variable. Y is half into 10 minus 2x minus pi x plus half pi x square. Let us open the brackets. We get 10x minus 2x square minus pi x square plus half pi x square. These two are like terms. Minus 1 plus half is minus half. Therefore, it becomes 10x minus 2x square minus half pi x square. Let us differentiate with respect to x. Differential of 10x is 10 minus 4x minus half pi times 2x. Equate the first derivative to 0. Therefore, we get 10 is equal to 4x plus pi x. X is common. Therefore, the answer for x is 10 divided by pi plus 4 meters. Let us do the second derivative test. D square a over dx square. 10 is a constant, derivative is 0 minus 4 minus pi, which is negative. Therefore, area of the window is maximized. When x is 10 divided by pi plus 4 meters. After completing the second derivative, see the question. Find the dimensions of the window. The dimensions of the window are length, breadth and the radius. So, let us write all three dimensions. We will find the breadth, which is y. Y is half of 10 minus 2x minus pi x. Let us substitute. 20 divided by pi plus 4 minus pi x. So, 10 pi divided by pi plus 4 half into LCM is pi plus 4. We get 10 pi plus 40 minus 20 minus 10 pi. 40 minus 20 is 20. We have divided by 2, which gives as 10 over pi plus 4 meters. Now, let us write all the dimensions. length of the window is x, which is 10 divided by pi plus 4 meters, and width of the window is y, which is length of the window is 2x. So, it is 20 divided by pi plus 4 meters. Width of the window is y, which is 10 divided by pi plus 4 meters, and the radius of the window, we took it as x, which is 10 over pi plus 4 meters. These are the dimensions of the window which has the maximum area to admit maximum light. Question 12, very important question. A point on the hypotenuse of a triangle is at a distance a and b from the sides of the triangle. We have a right angled triangle and we have a point P on the hypotenuse, which is at a distance of A and B. So, I have drawn the perpendiculars. Let me name the triangle as A, B, C, Q and R. PQ is perpendicular to AB and PR is perpendicular to BC. And we will take these two angles, corresponding angles, they are equal. So, I am taking them as theta. Angle APQ is equal to angle PCR is equal to theta. Write the reason, they are corresponding angles. We will take PQ distance as A, PR as B, or you may interchange and take PQ is equal to A and PR equals B. Let us use this triangle. In triangle AQP, I know the adjacent side of theta. So, let us use cos theta formula, which is adjacent side divided by the hypotenuse AP. Therefore, AP will be A divided by cos theta. 1 divided by cos theta is secant theta. So, this length is A secant theta. I have written that distance in the figure. Now, next in triangle PCR, let us use this triangle. I am using sin theta because I know the opposite side of theta, which is B divided by the hypotenuse. Therefore, PC will be B divided by sin theta, which is B cosecant theta. Let me write that distance here in the figure. Now, let H be the hypotenuse length. I have to minimize this length, and the total length of the hypotenuse is A secant theta plus B cosecant theta. Let us differentiate with respect to theta. Derivative of secant theta is secant theta into tan theta, and derivative of cosecant is minus cosecant theta cot theta. Be thorough with all the differentiation formulae. Equate the first derivative to 0, and let us change everything in terms of sin and cos. Secant is 1 by cos, tan is sin divided by cos, equal to B times cosecant is 1 by sin theta and cot is cos theta divided by sin theta. Let us cross multiply, we get sin cube theta over cos cube theta equals b by a. Tan cube theta is b over a, therefore tan theta will be b divided by a whole raised to 1 by 3. Now the second derivative test, we will differentiate this with respect to theta. Let us differentiate this step. A into, we have to use u and v. Product rule, u dashed is secant theta into tan theta, v is tan theta, into tan theta will give you tan square, plus u into v dash, differential of tan theta is secant square theta. Secant square theta into secant theta will become secant cube theta, minus b times, we will use product rule for cosecant theta into cot theta, u and v. U dash, differential of cosecant theta is minus cosecant theta into cot theta, into v is cot theta, therefore cot square theta, and then cosecant theta into derivative of cot theta is minus cosecant square, therefore it becomes minus cosecant cube theta. We will remove the minus sign, therefore this middle sign becomes positive, and I can say that this expression is greater than 0. Write the reason, because theta is an acute angle. Therefore, all trigonometric ratios are positive. It is a first quadrant angle, and we have plus sign throughout, therefore it is greater than 0. Therefore, the hypotenuse is minimized when tan theta is cube root of b by a. You may get a by b also in this case, it depends how you have taken a and b in the figure. Second derivative test is over. Now check the question. We have to show that the length of the hypotenuse is a raised to 2 by 3 plus 2 by b raised to 2 by 3 whole raised to 3 by 2. We have written the hypotenuse length as a secant theta plus b cosecant theta. We know the value of tan theta. So, let us use triangle method. Tan is opposite by adjacent, therefore, hypotenuse will be sum of their squares root of. From this right triangle, secant theta, secant is hypotenuse divided by the adjacent side, plus b times cosecant theta is hypotenuse over opposite side. Now, root of a raised to 2 by 3 plus b raised to 2 by 3 is common. Here we have a raised to 1 divided by a raised to 1 by 3, 1 minus 1 by 3, which will become a raised to 2 by 3. Similarly, b power 1 divided by b raised to 1 by 3 will become 1 minus 1 by 3, b power 2 by 3. Therefore, the answer is a raised to 2 by 3 plus b raised to 2 by 3 whole power 3 by 2 units. So, this is the length of the hypotenuse. Question number 17. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius capital R. So, capital R is a constant here. capital R is a constant. And now we are going to inscribe a cylinder. Radius of the sphere is R. Center of the sphere will be the midpoint of the height of the cylinder. So, this will be h by 2. Let the radius of the cylinder be small r. So, R and H and V are the radius, height and volume of the cylinder. We have to maximize the volume. Volume of the cylinder formula is pi r square h. We have to change it in terms of one variable. Let us make use of this right triangle. In this right triangle, use Pythagoras theorem. Hypotenuse is r. So, r square is small r square plus h by 2 the whole square, which is h square by 4, which is h square by 4. Substituting for r square will be better. We can avoid the square root sign. Therefore, we get pi times r square minus h square by 4 times h. Open the brackets to avoid product rule. R square h minus h cube by 4. Now, differentiate with respect to h. R square, r is a constant here, 3h square over 4, and equate the first derivative to 0. Therefore, we get r square as 3h square over 4. 4r square is 3 times h square. Therefore, h is 2r divided by root 3, and this is the result to be proved. Now, the second derivative test. Let us differentiate d square v over dh square. Pi is a constant, r square is a constant, and this will become 6h by 4, which is negative. Therefore, V is maximized when h is equal to 2r over root 3. Now, what else we have to prove? Also, find the maximum volume. Therefore, the maximum volume is equal to, let us make use of this step, or you may use the next step also, pi times, we have to give the answer in terms of capital R, because that is the given quantity in the question. Now, let us substitute for h square, 1 by 4 times, h square is 4r square over 3 into h, 2r divided by root 3, pi into, take LCM, 3r square minus r square will become 2r square times 2r divided by root 3. Therefore, the answer is 4 divided by 3 root 3 pi r cube, cubic units. This is the maximum volume of the cylinder possible in terms of the radius of the sphere. Question 18, very important question. Show that the height of the cylinder of greatest volume that can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3 that of the cone, and the greatest volume of the cylinder is 4 by 27 times pi h cube into tan square alpha. So, it is inscribed in a cone. Now cylinder is inscribed. Height of the cone is given. This is given as h, and semi-vertical angle is also given. Semi-vertical angle is alpha. Let us take capital R as the radius of the cylinder and capital H as the height of the cylinder. Let capital R and H, V be the radius, height and volume of the cylinder. We will use this right triangle, and in the answer tan alpha has been used. Therefore, we will write tan alpha from that right triangle. It is R divided by the adjacent side. Adjacent side is small h minus capital H. Therefore, h minus h is R over tan alpha. Now, we have to decide whether we are going to substitute for capital H or for capital R. Volume of the cylinder is pi r square h. Be careful, we have used capital letters for the dimensions of the cylinder. And we have to prove that the height of the cylinder is 1/3 that of the cone. So, we need h. Let us substitute for r, or you may substitute for h also. Therefore, h is h minus r by tan alpha. We can avoid squaring. Pi r square times h is h minus r divided by tan alpha. Open the brackets. Pi r square h minus pi r cube over tan alpha. I am doing differentiation with respect to capital R. You can do this sum with respect to h also by substituting for r. Here pi and h are constants. Differentiation of r square is 2r. Pi by tan alpha is a constant. Derivative of r cube is 3r square. Equate this to 0. 2 pi h r is equal to 3 pi by tan alpha times r square. Therefore, capital R is 2 by 3 h tan alpha. Let us do the second derivative test. D square v by dr square is equal to 2 pi h is a constant. Derivative of r with respect to r is 1 minus 3 pi by tan alpha is a constant. Derivative of r square is 2r. Now, let us substitute for r. R is 2 divided by 3 h tan alpha. We have 2 pi h minus 4 pi h, which is negative. Therefore, V is maximized. When R is 2 by 3 h tan alpha. Now we have to show that the height is 1/3 that of the cone. So let us make use of this result. H is equal to, let us substitute for R. R is 2/3 H tan alpha divided by tan alpha. Take LCM, 3H minus 2H over 3, which is H by 3. That is what we have to prove. Therefore, height of the cylinder is 1/3 that of the cone. Now, next result, we have to prove that the greatest volume is that given expression. Therefore, volume is equal to for volume we will use this, which is pi r square H minus R by tan alpha. Which is equal to pi. We have to substitute for R. R is 2/3 H tan alpha the whole square times H minus R by tan alpha is 2/3 H. Tan alpha will get cancelled. This is pi 4/9 H square tan square alpha, and this will be H by 3. Therefore, the answer is 4/27 times pi H cube times tan square alpha. That is the answer to be proved. Example 36. Page number 226. Let AP and BQ be two vertical poles at points A and B respectively. This is AP and this is BQ. AP is 16 meters and BQ is 22 meters. AB is 20 meters. Then find the distance of a point R on AB from the point A such that RP square plus RQ square is minimum. So, we will take that as S. We have to minimize this, RP square plus RQ square. Let us take the distance AR as x meters. Therefore, RB will be 20 minus x meters, because the total length is given as 20. RP square using this triangle will be 16 square plus x square plus RQ square using this triangle this length is 20 minus x. Therefore, it is 22 square plus 20 minus x the whole square. Now, let us differentiate with respect to x. 16 square is a constant which is 0, differential of x square is 2x, 22 square is also a constant, derivative is 0. Now, let us differentiate the power first. and then the base. Don't forget to differentiate the base. We get 2x minus 2 times 20 minus x. Equate the first derivative to 0. 2x is 2 times 20 minus x. Therefore, 2x is 20. We get x as 10 meters. Second derivative test, d square s over dx square is equal to, we are differentiating this step, 2 into 1 minus 2 times minus 1. Minus and minus will become plus, which is positive. Therefore, s is minimized. When x is 10 meters. Now, what do we have to find? Find the distance of the point R on AB from A, that is AR distance. We took it as x, therefore, the answer is 10 meters. Example 37. If length of 3 sides of a trapezium other than the base are equal to 10 centimeters. So, these 3 sides are equal, 10 centimeters each. Find the area of the trapezium when it is maximum. Let us draw altitudes. These two triangles are congruent by RHS congruency. We will take this as H. This is a rectangle, so this length is 10 centimeters. We will name the figure A, B, C, D, M and N. AM and DN are drawn perpendicular to BC. Triangle ABM is congruent to triangle DCN, RHS congruency. AM is equal to DN equal to H, and let us take BM equal to NC equal to X. This is by CPCT. Therefore, the length of this base will be 10 plus 2x. Now, area of the trapezium has to be maximized. Area of the trapezium formula is a half h times a plus b, half into height is from this right triangle, it is 10 square minus x square, root of 10 square minus x square, and A and B are parallel sides. AD is one parallel side and BC length is 10 plus 2x. We can take 2 out from this. Which is 10 plus x. We will square both sides to remove the root sign. This is equal to, let us factorize the first term, 10 minus x into 10 plus x into 10 plus x the whole square, which will become, I will take this as A1, 10 minus x into 10 plus x the whole cube. differentiate a1 with respect to x. U and v. U dashed is minus 1 times 10 plus x the whole cube plus 10 minus x into, differentiate the power first and then the base. Differentiation of plus x is 1. Let us remove the common factors. 10 plus here whole square, 10 plus x the whole square is common. We get minus 10 minus x plus 3 times 10 minus x, which is 30 minus 3x. 10 plus x the whole square into 30 minus 10 is 20 and minus 4x. Equate this to 0. We get two answers. X cannot be negative. Therefore, x is 20 over 4, which is 5 centimeters. Let us do the second differentiation. We will differentiate this step. U and v. U dashed is 2 times 10 plus x into 1 times 20 minus 4x plus u v dash. This is minus 4. No need to simplify this expression. We are going to check only whether it is positive or negative. Let us plug in the value 5 for x. The first term becomes 0. The second term is 15 square minus 4, which will be negative. Therefore, a1 is maximized. When x is equal to 5 centimeters. If a1 is maximized, a will be maximized. And what else we have to show in this question? Find the area of the trapezium. Therefore, the area of the trapezium is equal to, we wrote the area as, here it is. This is the area of the trapezium. Root of ten square minus x square times 10 plus x. Substitute x as 5. 100 minus 5 square is 25. 10 plus 5 is 15. Root 75 times 15. 25 can be removed outside. 15 times 5 root 3, which is 75 root 3 centimeter square. This is the area of the trapezium. Example 38. Prove that the radius of the right circular cylinder of greatest curved surface area, which can be inscribed in a given cone, is half that of the cone. A cylinder is inscribed. Let us take capital H as the height of the cone and capital R as radius of the cone and small r as radius of the cylinder and small h height of the cylinder. Now, this triangle is similar to this triangle. So, sides will be proportional. We will name that triangle. Let this be A, B, C and this D and E. Triangle ADE is similar to triangle ABC. A similarity. Therefore, corresponding sides will be proportional. DE corresponds to BC is equal to AD corresponds to AB. Don't write DB. DB is not the side of the triangle. DE length is R divided by capital R is equal to AD is capital H minus small h divided by AB length is H. RH by R is equal to H minus H. Therefore, H is this. Greatest curved surface area. Let the curved surface area be, the curved surface area of the cylinder is 2 pi r RH. Now, we will substitute for H. We can substitute for R also, but we have to get a result in terms of radius. That is why I am eliminating H. H minus RH by R. Open the brackets to avoid product rule. The variable here is R, small r. Let us differentiate with respect to R. 2 pi h is a constant. Derivative of r with respect to r is 1. 2 pi h by r into 2r equated to 0. 2 pi h equals 2 pi h by r times 2r. Therefore, r is equal to capital R divided by 2. That is the result which we have to prove. Radius of the cylinder is half that of the cone. Don't forget to do the second derivative. It carries 1 mark. D square C by dr square is 2 pi h. It is a constant. So, 0 minus 4 pi h by r into derivative of r is with respect to r is 1. Therefore, it is negative. C is maximized. When r is equal to r divided by 2.